example 11 is asking us about what happens if we add an angle to 90 or 270. How does that mess with stuff? And it's going to be a lot different than what we've seen before because those parts shift in a different way. They have a different symmetry to what we're used to. So let's start with our angles. So we normally start at 0 degrees, we move to 90 degrees, we then move to 180, to 270, and then lastly back to 360, which is where we started. 0 and 360 have the same properties. So what I'm going to do is I'm going to start talking about this angle theta. So I'm going to draw one out just for illustrative purposes, and I'm going to comment on it, and we're going to base the rest of our answers off of that. So we're going to have to think of how they relate to each other. So let's look. So I'm going to draw this angle theta and try not to draw it like a buffoon. Okay, so we've got this theta here. So we're talking about this angle moving up. So let's think about not specifically, but just the general properties of what that angle has. So if we talk about cosine, so the cosine of theta, relatively, that's a pretty large number, right? It's pretty far off to the right. That's what cosine does. It's the measure of the x, how wide out that angle is. It's also a positive number. So then we talk about sine of theta. Well, the sine of theta, that's kind of small. It's not very high up. And it's also positive. So that's important to think about. So think about the magnitude. How big is that number compared to what it could be? And then lastly, I'm going to talk about tangent. Well, tangent's the slope. This seems like it's a kind of a small slope, but it's also positive. So what's going to happen when I move theta off of one of these lines, 90 or 270, and how does that relate back? So this is where our mind is trying to think of, is not only like, is it positive or negative, but how large is it in comparison? So the first one asks us about the sine of 90 plus theta. So what happens if I add the same amount of theta, and what happens to the sine? Well, the sine of 90 plus theta, so that appears like, okay, so that's like a large number. And it's positive. Well, if I look down here, a large positive, I see, right? The same amount that cosine is large in the original theta is the same amount that the sine is large in 90 plus theta. So the sine of 90 plus theta is actually the same thing as the cosine of theta. They're identical because of how much magnitude they get. Because as we move 90 degrees around, we're shifting the size or the magnitude from the cosine to the sine, because they are what we call co-functions of each other. That's why you see sine, S-I-N, and cosine, which is just a co, right? It's just added on, because they kind of share this thing where when we shift them by 90, they actually work together very well. So the sine of 90 plus theta is always going to have the same level of magnitude as the cosine of theta, and they're going to share the same sign, which is very, very important. It's always going to work this way. So, quick example, the sine of 100 degrees, which is very similar to what we have in this problem, is the same thing as the cosine of 10. They're the same amount of size and the same sign of each other, and so they're always going to be the same. So anytime you add 90 to an angle, you're going to get the same value for sine as you had for cosine originally. So let's see. Let's move along. So the second one asks for the cosine of 270 minus theta. So let's see what kind of properties 270 minus theta has. So 270 minus theta would be going backwards. So we go down. So let's think. So the cosine of 270 minus theta compared to the original. Well, the cosine of 270 minus theta, so we know this looks like kind of a small value. It's not moving very far off the axis. It's not very far. And we know that it's a negative number. Well, it's going to deal with its cofunction. So its cofunction is sine. Well, notice that the original angle, the sine was positive. But the cosine of 270 minus theta in our example, it's going to be negative. So this works out to where the cosine of 270 minus theta is actually the opposite of what our sine of theta is. It's the opposite value. And so by looking at how the magnitude of them again, we can sort of relate that this is what's going to happen. So we can say, okay, hey, the cosine of, let's say, 200 degrees. So 200 degrees, for example, that's the same thing as the opposite of the sine of 70. Because cosine and sine, they don't work 180 degrees apart from each other. They work in this kind of rule of 90s. And 270 is just kind of a little bit, off of 90. We can think of it as backwards 90 in sort of a way. Instead of plus 90, it's back 90 from 360. So we can see this sort of relationship evolving if we think about the magnitude again of these values. And so, cosine of 270 minus theta will always be the negative sine of theta, or the opposite of the value of theta. Now let's go to our last example. Yay! So we look at the tangent of 3 pi over 2 plus theta. So now we got to rethink things a little bit. Oh, okay, let's rethink. So normally we start out at 0. Well, if we're talking about radians, we move to pi over 2, and then pi, and then 3 pi over 2, and then up to 2 pi. So we've got our angle. Guess what? The way I drew it, it still has the same values of sine, cosine, and tangent, right? It doesn't matter, we're just talking about angles slightly differently. So 3 pi over 2 plus theta, same amount. So what happened to the tangent? What happened to it? Okay, so that's important. So I'm going to look here and say, okay, right, well, so the tangent of 3 pi over 2 plus theta. So this value is very large, right? This is it's a very steep line. This is large. And it's also negative, right? Because it's going down. Now, you're tempted to say, hey, well, what is it, just the opposite of cosine? No, it's not. And that's because when we deal with moving off of pi over 2 or 3 pi over 2, the same thing as 90 or 270, when we move off of those, we go with what their cofunction is, right? We go with the cofunction. And so what we have to figure out is, what was the cofunction of tangent? What's the cofunction of tangent? Well, that's cotangent, right? So let's think about the cotangent of theta, for example. The cotangent of theta is going to be, in our green example here, this theta, it's actually a very large value. Now you may say, how do I know that? Well, cotangent is the reciprocal of tangent. While tangent is small, cotangent is large. And when tangent is small, or tangent's large, cotangent is small. So a cotangent value that is large and positive versus a tangent value that's large and negative. So how do we make them work? Well, this is how we make that work, right? We're going to say, so the tangent of 3 pi over 2 plus theta, so that we know that tangent value is going to be large and negative. Well, if our cotangent value was large and positive, we just do the negative version of that. So this may seem tricky to you. It is very tricky. But what we want to think about is these cofunctions. So we can get back to the same function if we move off of 0 or pi. But when we move 90, we can't do that anymore. And that's why these cofunctions exist to begin with. Sine needs cosine when we start talking about shifting off of 90 or 270. Just like secant and cosecant need each other when talking about moving off of 90 and 270. And tangent and cotangent need the same thing. What we want to think of is visually, are we dealing with a positive or negative number? Or is it large or small? How does that relate back to the other thing? When you get the practice with it, you'll start to see and understand how we can relate these to each other. And what's going to help is that when we do this and we get to patterns and solving equations, you're going to start to understand the logic, and it's going to make these problems a lot easier. Initially, I understand it's tricky, but just keep your head up, just keep working with it, and try to see visually this side over here. Try to visually see what's going on, and that is going to aid you a lot moving forward.